Um, Nice to be presenting here. And yeah, I'm Rick Carr. I'm farm director at Rodale Institute. This is just a brief overview of my agenda there that I'm going to be discussing. And I'll be taking it in some other directions as we move through this. But I do want to allow adequate time for questions. We could use the chat function if you're familiar with that, and I'll try to monitor that as we go along. But given the nature of the topic, we could save questions to the end, or I'll probably take a pause somewhere in the middle and address some of your questions. So please feel free to use the chat function for any of your questions. And we're going to take a little practice with it right now because I'd like to do some introductions. Doing these online presentations, it's somewhat challenging for the presenter because we like to know our audience. So if we can just take a 1 minute of what everybody's professions are and who am I talking to. And while you're doing that, I'll give you a background of myself. Farm director at Rodale Institute. I've been with Rodale since 2013, in 2013, and I was initially hired as the compost production specialist, and where I managed the Rodale's large scale compost operations. And I was part of the research team. My background at that time was mostly in research and less of farming. It's now taken a different direction, where I oversee all farm operations at 9 of our different farms that we have across the United States, in Georgia, Iowa, Washington, California. We do have another location in Italy. So we've grown a lot as an institute, but yeah, so a lot of, let's see what we have going here. Cut flowers. Okay. Environmental scientists. Thanks, Kathleen. Caretaker volunteer. And if it's okay, we keep this going. I'm assuming everybody's a composter here. Otherwise, why would you sign on? What about scale? Cut flowers, a lot of cut flowers. Landscape, great. Vineyard, nice. Anybody, a lot of commercial composter, okay. Solid waste. Farm 20 acres, nice. Glad everybody's using the chat function here. I'm going to keep monitoring that. Keep this dynamic if that's okay with everyone. Master composter. Yeah, actually, good to see a master composter there. My hat, if you can see it, says master composter on it. When I got my first master composter hat at when I was working at Cornell Cooperative Extension, and I was in plant pathology. And when I first started, there was a gentleman I was working with. We were studying diseases of onions. At Cornell, you could study just about anything. And me and this other guy, when the only two there, we were trying to save a vegetable that makes you cry. But he was wearing a hat that said master composter. And my father had compost back in the day, and I didn't know what he was doing. All of that, it smelled and it was hot. But I saw this gentleman with a hat that said master composter. Said, how do you get one of those hats? And he said, you got to go through the program. And that's where all of this started for me. That was in 2007. So I've taken it leaps and bounds since then, from doing getting a graduate degree in understanding how compost can suppress diseases, to on-farm composting, managing compost yard. And so that's where I'm going to go into today, is what I've been doing, I guess, and monitoring and testing compost from a practical standpoint. All right, thanks for using all that chat, everyone. I'm going to keep looking at that. All right, so Rodale Institute, this site you're looking at here, we're 386 acres, located in Kutztown, Pennsylvania, just a little east of or a little west of Allentown. But this is most of the site that you see here, quite diverse. We do have apple orchards, we have a hog facility, we have livestock and cattle and chickens, grain operation, vegetables, and large scale composting facility. So what the off to the left there, that's just part of it, where the picture is being taken. The another compost operation is there underneath the picture. But what we do is we study soil health, and since this site we started here in 1971, we've been testing and researching best practices for organic and transitioning agriculture. And what our motto has been since 1949, when J.I. Rodale first came up with it, is healthy soil equals healthy food equals healthy people. And so we believe the root of all of our problems can be resolved in agriculture, and really focusing on organic agriculture. Why compost? So this is I guess a compost operation that I visited in Argentina, and I'm going to say that why compost? Well, I mean, nature can break this down, but why do we do it? Is because we can do it faster than nature if we put everything together in the right, setting, and you have your nitrogen materials, nitrogenous materials, and your carbon materials, your browns and greens. You can do that better than what you're seeing here. So in the background, there is a compost pile, and that's probably maybe a year and a half old, that they had actually managed it. So my simplest definition of composting is going to be managed aerobic decomposition. So the pile there I'm standing next to, that's not managed. And that's basically what composting is going to be management. And aerobic is because we want to have oxygen in there. If not, we're going to get anaerobic, and we're going to start getting odors. And we'll be able to, I'll be discussing that a little bit later, of monitoring the compost pile for odors and temperature. And decomposition, basically, it's just going to be doing what nature can do, but when we put it all together, we're going to be doing it a little faster. And so with that, I'm going to turn this to just solid waste by the numbers. Again, this is getting to why compost. So what you see here is the trend of solid waste management in the United States. And the EPA puts this out. They have a newer version of this, this fact sheet. They do this about every 3 to 5 years. But basically, let me move something around. Basically, what you're seeing is the trend of solid waste generation. And this is stuff that you put out on your curb. And it's not what you flush down the toilet, but it's what's going to the curb. So this is your recyclables plus the trash. And if you are a gambling person, you can bet on waste. And in composting, there's two guarantees: is that there's always going to be waste, the human invention, and the other guarantee is there's always going to be death. And composting can take advantage of both of those. And so what we're seeing here, the top line, the blue bar or the blue line, is total waste generation. It's just going to keep going up. The more people we have, the more waste we're going to be generating. And then per capita is the orange line there. And so what that's showing is that individually, we are throwing out 4.4 pounds of waste per day per person. It's pretty staggering to see it that way. And when we look at it for recycling, we could see that there's, somewhat more positive. Recycling has increased since 1985. And a lot of that is because the industry plus education has gone up. But our rate as our rate in, globally, 34% recycling rate, that is much lower than European countries. They're 60% or above, if we want to compare that. And so this is the management. This is basically, you can look at this pie chart to seeing how do we spend our efforts, as a nation in composting and recycling. And most of it, we're just landfilling. That's where we spend most of our efforts. These two here is showing a pie chart of what we generate, the solid waste materials that we generate. And I'm going to come to a point in all of this, is that the one on the left, the pie chart on the left, is the total waste that we generate. That's basically what you're putting out to the curb, regardless if it's recyclable or trash. This is what's going to the curb. So ones that we want to focus on, the yard trimmings in regards to composting, yard trimmings and food waste. These are things that are easily compostable in any backyard or compost facility. So we're throwing out about 15% of the food that we purchase, and yard trimmings 13%. Of this material, what is on the right now is what is recycled in compost. So for the composting operations and the food, only 2% of that is recovered through composting programs, which have been increasing over the years. But it's either for composting or incineration. And with the yard trimmings, we got about 24% there. A lot of that increase there is because of mandates, township mandates, borough mandates that don't permit dumping of yard debris. So what's left over is what this pie chart showing is what's left over in the landfill. This is the contents of the average US landfill. And that picture there is the landfill that Rodale sends their material to. That's Birdsboro landfill. And the point I want to make is that 21% of the contents in a landfill, and I think it's a little up from 2014 when this was produced. I think it's closer to 24%. But here, 21% of the contents in a landfill is food waste. And when the discussion of we have to feed 9.5 billion people, I always go back to stop wasting. And there's waste everywhere. It's definitely in agriculture as well. I'm going to show some pictures here, but we can stop wasting food. And it's from the time when you purchase seed to growing it, processing, delivering, packaging, and then restaurants, and then you have your you go to the restaurant and you have your takeout and your little box of food that you don't eat and let it sit in your fridge for a couple days, and eventually it's just going to go into your compost pile. Let's be honest there. So anyway, stop wasting food, and we're going to be showing here what some of the agricultural wastes and how we can monitor those and track that and then process them. So now we're getting into the composting operation. So this is one of the compost yards I have at Rodale, and you can see there's leaf debris there and a finished compost pile. But what we have, we're quite a diverse operation here. So we have a diversity of feedstocks. I have leaves that come in from 6 different municipalities. I have grass that comes from 3 different municipalities, and then all the stuff that we generate on farm. We also get some wood chips from some of the tree trimmers in the area as needed. But the diversity of materials is going to be anything from vegetable materials, straw, manures that we have. There's a huge pile of not weed seeds, but a huge pile of seeds that we couldn't just sell, went moldy. We do have animal mortalities. It's unfortunate, but it does happen. And Cornell has written a book on mortality composting. And so that's just a picture there that I did want to bring up of monitoring. And so that is, a cow. And then I'm a hunter myself, and I wanted to show what the power of composting can do. This is after 9 days of processing a skull in compost. 9 days, that's all it took to get it to that point. And after 19 days, I was able to get it to that. So this is my son here. You're going to see a lot of my kids throughout my pictures. But that is a skull, just 19 days of composting and of processing that, and then mild bleach solution for a couple hours. So pretty impressive mortality composting. I wanted to show this only because of again the power of compost. Yeah, it could decompose stuff, but it also can grow things. I think somebody did a seed bomb on my compost pile, and it's Gliome that they had thrown in there and some other stuff. I let it go, but it was a nice year to see that growing out of the pile. Monitoring temperature. The National Organic Program that I have to operate through for composting dictates that I have to monitor temperature, and it says that compost to be certified for use on organic land needs to be processed for 15 days, and during which time the pile must maintain temperatures between 131 and 170 degrees Fahrenheit for 15 consecutive days. And I have to turn it a minimum of 5 times during that process. But it doesn't tell me how I should be monitoring temperature. And the reason why we're monitoring it, though, just for the composting perspective, is that it's going to tell you, one, how things are processing. And it tells you more than just of is it active, is it not active, but it tells you that is it anaerobic or aerobic. So measuring oxygen in compost, this is an article on Biocycle. I found very interesting that temperature can also tell you, something about odor emissions. And so Henry and Dalton's law here of thermodynamics are going to say as the temperature goes up, the amount of oxygen that can dissolve into water goes down. And so why is that important? Is that less oxygen you have going into your pile, the more anaerobic it's going to become, and then the more odors that you can produce. And so we want aerobic conditions in our piles. Aerobic conditions are they're going to be less odorous, the noxious odors. You're always going to have an odor in compost, but whether or not it's noxious is difference of having angry neighbors or pleasant neighbors. So measuring temperature. If your temperature is not getting high, if it's not reaching that range, and typically in your backyard, it probably won't be getting above 130 unless you have some ideal conditions in the middle of summer. I consider myself an expert in composting and backyard composting. And my pile in my backyard doesn't get that hot. But it also doesn't smell either. So monitoring temperature. How do we do that? So since I came to Rodale, I created my own style of monitoring that I implement across all my piles. And So here is a two different piles showing different temperature profile. And I have image here of where I'm collecting the temperatures. And then so these two graphs here are showing that the core temperatures that you could see, the core of the pile, and then the surface temperatures. And it's not the surface, but it's close enough to the surface. So I wanted to measure the temperature in the center mass of the pile, and then something that's a little bit more on the outside. And for submitting my my records for certification, organic certification, I take an average of all these temperatures. But I just wanted to show and highlight that as the pile is becoming more active, temperatures are changing both in the core of it and then on the surface of it. And when you see the pile temperature fluctuating, like in pile 30, that's different turning events. So I'll turn the pile and it'll spike again. And when we're turning compost, it's not adding oxygen. It'll add oxygen initially, but that's quickly consumed by the microorganisms. But what it's really doing is exposing new surfaces to decomposition. So that's one of the goals of turning, and that's why you're seeing these fluctuating temperatures. Is you turn it, and now new surfaces are allowed for decomposition. So as I mentioned, the National Organic Program doesn't tell you how to collect temperature. EPA has the similar rules for compost operations. They don't tell you how to, they just say you have to record it. So theoretically, I could have a compost pile that's 100 yards long and take one temperature reading and submit that. I don't do that, but what I do instead is I have this is how I collect all my temperatures. I want to get an idea of how the pile, an image of how the pile is actually breaking down and the temperatures at different locations, because it might not be uniform across the entire pile. And then I take an average of all of these. Any questions on monitoring temperature? Take a little pause here. Okay. Visuals. That's another tool that you're going to have. You have your thermometer, your nose, and it's the visuals then. So we're looking at compost, and every time you're turning it, you're examining what it looks like, and what stage of decomposition it's in. And you could be either, turning with a pitchfork or using a compost turner, but we're always examining our pile. Is it steaming? Do you have any odors? So we're looking at stuff. So just take a pause here and just to say, what kind of things are you seeing when you look at your compost pile? These are the pile from my yard here at Rodale. We're seeing a lot of stones in there, some woody debris, and always the surface of the pile is going to look different from what's inside of it. Inside it's going to look more moist, dark, crumbly. And so we're examining what we have in our pile and what stage of decomposition that it's at. And we're looking at our feedstocks, and we're measuring the feedstocks too. I use my unit of measurement at Rodale is my bucket loader. So how many buckets of this mixed veg farm waste? And I'm trying to quantify as much as possible. And so when you have a pile like this, it's difficult to quantify. A pile of leaves, pile of grass is in the background, pile of wood chips, pile of manure, landscaping debris. All those things are easily quantified, but at least in agriculture, even community composting, this is what I would consider a mixed vegetable farm waste, where it's going to have straw. There's some garlic scapes there, or garlic shellings, pumpkin, tomatoes, just stuff that I can't quantify because it's at too small of a level, and it's coming at different times of the year. And so all my stuff is quantified at Rodale. I know the contents of all my piles. My piles are different from year to year. And throughout the year, some piles are just 100% leaves, some piles are leaf grass mix. And then I'm processing all the waste that we have at Rodale. So I have a diversity of feedstocks, and most composters might have that as well, unless they're just dealing with municipal waste like yard debris and leaves. And I guess, you know, with composting, we see things in a different lens. And this is in a, you know, probably about 200 feet of wasted pasture that was harvested and never used, and they got wet, and now it's a waste material. So we see things in a different lens. When I see a pile like this, I see potential compost. So there's a lot of nitrogen in that pasture. That was that hay mix there. And I have to process that into compost that is going to get put into the field for vegetable or grain production. Monitoring compost. These are my two girls here. It's definitely clearly a forced picture of what's going on in my backyard. But we're monitoring it many different ways through what we put out there. You know, you're using your bucket, you have your thermometer, visuals, and odors. There's a lot of different tools we can be using to monitor it. Again, at the larger scale, it doesn't matter what scale we're at, we're using the same tools. The only thing, the best tools are going to be, you know, your thermometer or your nose or visual aids, whether it's at your backyard or a large scale. The only thing that changes are going to be the equipment. So it's a pitchfork or it's a compost turner, but we're always examining it. And so this shot here, the materials doesn't seem to be fully finished, but if you look in the behind the turner, it definitely looks a little bit more finished than in front. So it's just visual aids of telling us, and it's steaming, so we know it's not completely finished, but it's giving us an idea of where it's at in the compost process. You can't manage what you don't measure. That was something one of our Mennonite farmers told me one time, and that's how true. And I have several notebooks on my compost operation, and this is just a screenshot real quick of things that I'm always measuring in my compost operation, trying to calculate. And the U.S. Composting Council does a great job on training people on how to monitor, measure the compost operation. And so just simple things of like every truckload, what is the volume of a truckload, how many truckloads you're going to need, what is the volume of my bucket loader, what is the volume of your compost pile, all that stuff we're measuring to monitor our compost operation. And it doesn't matter what scale you're at, if it's community composting, backyard, large scale, we want to know the amount of material coming in, and then the amount of material we're processing, and then what we can get out of that. And so this is just a small example of measuring, and documenting the compost operation. Moving on to something a little much more technical now. So this is, and Debbie after me, she's going to be interpreting some of these results. And so I sample all my compost piles for nutrient analysis. It's the only testing that I do for laboratory testing. I don't do the biologicals. I've done it in the past. I find it difficult to interpret the results, but from a land management, nutrient management perspective, the chemical analyses are fairly accurate. And this is just one of them that this is from Penn State, their Penn State University laboratory. And this is an average of 36 different compost piles. And so what you're seeing on top is just a breakdown of the materials I'm using. So 50% of my compost is going to be leaf material, and then followed by manure and our mixed veg farm waste. Some grasses are in there, showing my browns to green ratio. And it's about the age of testing. We are close to 2 years for my piles, but it could be anywhere from maybe 9 months as well. And then below that, we're getting into the actual test results. And what I like to show in my test results, so this is 36 different compost piles. They all had a different makeup, a different recipe. There could have been some overlap on, how much leaves are in there, 50% leaves, grass, doesn't matter. What it's showing is that what I really like to highlight is this one column of the standard deviation. All right, I don't know if you can see my mouse here, but just looking at the top of it, my compost piles are going to be an average of 7.7 pH and a plus or minus 0.4. And so I think it's nice to highlight that no matter what your compost is, it's going to fall within that range. And this is finished and cured compost. Very important when it comes to testing your material. There's no point in testing your material if it's not finished, because it's not going to be accurate results. And then looking at some other things, I know my compost is going to be about 1% total nitrogen, and that's not going to vary too much. And I'm not going to go into any more than that, other than the organic matter. That is another thing that we value in agriculture. We always want to boost our organic matter in our soils. Composting can do that by supplying, this is showing about 23% organic matter. We'll take a quick pause. You can see the mouse, great. But there was a question of what is the best temperature after the curing process to know the curing process has been reached? I have a static air process. Best temperature, what I find in my compost piles is once it gets down, and these are large piles, so I'm reaching 160 degrees for several weeks in my piles. But once it's getting down close to 110, it's holding temperature at that point is what I've seen. And then it's difficult to get it to ambient air temperature. So anything above, anything below 110, that's when I find that it's pretty well cured. It's still cooling down, but say I turn it at 110 degrees, it's going to cool it dramatically. So I think 100 below, and certainly at ambient air is going to be your curing stage. My percentages add up to more than 100%, and yes, they definitely do. What you're reading there, it's a little bit misleading. But if I make a pile, this is the average leaf usage I do in a pile, and I'm glad you brought that to my attention, because that probably should need some adjusting so it's more accurate percentages. You're also not probably seeing a lot of the other things like straw bales that I put in here, and they're less of percentage, but these are the bulk of my materials that I record. Thanks for pointing that out. All right, some of my best tests that I've done are going to be these. This is just in my backyard. This is one of the first times I've done this, and this is me becoming a master composter. And I took it upon myself to do a test like this because I get the question all the time when I'm doing outreach is, how much compost should I use? And your compost is going to be different from my compost. And so you don't want to tell somebody 100% compost. That's going to be great. You have no idea what their compost is. And so this is the free at-home testing for compost and addressing how much you should use. And so this is just growing. This is what I call my, some people call it grow outs. This is just a compost amendment bioassay is, how I technically call it. And basically you're measuring different rates of compost added to some kind of media. Either it's going to be, here I'm using sand, but there's, you could use soil, your own soil, or potting media. So it's the same test, and I get the same result every time I do this. And sand, it's inert material. So this is telling you the result of just the compost alone. And so when we look at plain sand here, you're going to see very little growth. A little bit of compost is going to go a long way. 10% amended, and this is by volume. And 10% amended by volume. And you're going to get, a big, in his cucumber seedlings here, 10 seedlings per pot, 25% seeing the same result. And then 50%, it starts going down, and then you get a big spike over at 100%. And in research, we like to do things in threes and replicates. And so you can see here, a top view of it. What we have, the great thing about the replicates is that you can see that there's great variability in 100%. And I'd never recommend anybody to grow things in 100% compost. It's just too much nutrients. It can be too hot, too many soluble salts that could burn seedlings. And in this case, it prevented seed germination. So over just top view, you can see 25, maybe 50% is going to be maximum growth that you're going to get out of compost. But when I let this continue over 15 days now, I want to highlight this done in the summer, and that this is showing one of the benefits of compost. Compost can hold moisture, and this is clearly showing that is that 10%, the sand, everything died in that. 10% didn't have the ability to hold enough moisture. 25%, again, it looked really good, a few days ago, but over time, it couldn't hold the moisture. And then 50%, while it didn't show maximum growth, possibly after 10 days, but now it's allowing things to survive, because it was holding that moisture. And that's clearly what this is showing. This is oat seedlings, and showing the same thing where you're going to get that typical bell curve of, 0, and I think this is in potting media. So it's not just sand here, but we get, there's plants are struggling at 0 and 10%. You get a boost in growth at 25%, 50% is looking pretty good, 75 is looking nice, but 100%, that's stunting growth. So you get that bell-shaped curve in this is potting media, soilless media, but you're going to get that classic curve. And this is one of the best tests that you can do if your own setting. And if you're a commercial operation, this is something you should be trying to do with a lot of different crops. And people are always going to ask, how much should you use? And these are simple bioassays, simple things that you could do in your backyard, in a commercial operation. And these are just nice visuals too, to show that, hey, you have potting media, and you add 50% of my product, my compost, and look at the benefit that you get out of it. It's really easy stuff to do. I also will say that when I use this, I do these tests. I do it in my test that I submit for nutrient analysis. I screen it to a 1/4 inch. I do that in my backyard. Actually, my backyard's a 1/2 inch, but I screen all the usually the woody materials and put that back in. So that's what you're seeing in these tests here. You definitely want to do that if you're submitting it for nutrient analysis. I'm familiar with how they conduct those analyses in the laboratory. And if you have a small chunk of a wood chip, that's going to throw off your analysis big time. Because they're only testing a small amount of what you actually send in. Again, another way of doing the tests, showing off, this is vermicompost and sand. Again, sand, seedlings are growing. Cucumbers are nice, they're easy to work with. So that's why you're seeing a lot of cucumbers in my assays. Easy to count the seeds. And then you get, you know, each one of these has 2 seeds per cell. So it's easy to calculate percentages of growth, of germination, but it's showing the similar bell curve. At sand, you have, there's adequate growth there, 10%, 25 seems to be doing all right. But I guess what this is showing is that 100% is going to prevent germination. And this is vermicompost. And the sand and Cornell mix. So Cornell has a great potting media, doing very good. I'm just doing the comparison of that. It's showing that Cornell's potting media to a vermicompost and sand mix. You know, pretty accurate. Question came up: would I use wood ashes in your compost pile, or add them later, or use not at all? Good question. And yes, I do put wood ashes. I have a wood stove at my house. I do add wood ashes to my compost pile. But there can be a point when you're adding too much of it. If you dump a bucket of wood ash in your compost at a small scale, that material tends to cake up and can prevent oxygen from moving through your pile. So you add it in small amounts. If it's a large pile, certainly. I mean, basically, you still have to manage that material, and either that or you dump it around your wood line, however you're going to put it in. But I either dump it directly into my garden, directly into the compost. But I do, or if I have too much, it's going to go in the tree line around my house. So yes, I do add wood ash. Another simple test here. This is compost extract or compost teas, showing different rates that I'm using. Again, I'm asking myself, how much should I use? And people are always asking that question, can you add too much? So these are different compost to water ratios that I did just by myself. And then you try to grow seedlings, just these basic grow outs of what's working. And this is just the seedlings grown in sand alone. So everything being equal, and you do everything in replicates. If I had just one of these, one cell, you might not get a full response. All right, so what I would like to do is open it up for some Q&A and allow people to ask questions and explain some of the testing that they have been doing. What do you find works? What doesn't work? Is there anything that I didn't highlight here that just basic at-home testing that you find helpful? And while people are using the chat function, I will say one thing that I didn't add to this. You can use the Q&A function as well, but becoming more popular, I just didn't have the slides to add, is the testing for persistent herbicides. And U.S. Composting Council is giving a presentation on that I think it's next week, but you can go to their website on full presentation or webinar on testing for persistent herbicides. And so I'm going to take this time while people are using the chat function to discuss persistent herbicides. And what is that? Those are herbicides that are able to persist in the environment for extended periods of time and remain active. So something like Roundup. I always get the question in my presentations when I'm doing like on-site presentations, and I tell people I'm using grasses. And I get them from municipalities, and they say, are you concerned with the chemicals people put on their lawns? I certainly am concerned with the chemicals they put on their lawns. I'm cognizant of it, but I know the nature of those chemicals. Something like Roundup, it has a half-life of about 6 to 7 months, meaning that it will break down by itself in the environment. Something like DDT, its half-life is measured in almost a decade. I think it's close to like 12 years or something. So that is a persistent herbicide or pesticide, but it's no longer in use. It was a early 2000s that this subject became popular because there was I think it was Spokane County in Washington, that a compost operation went out of business because it was selling its compost that had a persistent herbicide in it. And so people were trying to grow their vegetables only to find that they were killing them. And they couldn't figure out why. But then when they had their compost tested, they found an herbicide, I believe it was clopyralid. And we have now seen clopyralid is a broadleaf herbicide, and there's derivatives of it, aminopyralid, that do persist in the environment. And it's a broadleaf herbicide that was commonly used in horse operations and horse farms. And when you are, if you ever been by a horse farm, you can see these nice lush pastures, grass pastures that don't have many broadleaf weeds in them. So they're applying that, killing all of the broadleaf weeds. You get a nice pasture, you make hay from it, and now the horse is fed that. The herbicide, clopyralid, is still active. It hasn't broken down. It's going through the horse's body, comes out in the manure. It's composted, and that's what was happening at this operation. It was composted, and it's still very active. And then it goes into your garden, and even at 3 parts per million, it's still you could see how active it is. It still has symptoms on clover. So the at-home test, if you're concerned by this and you are suspecting that there could be persistent herbicides, we'll say first, know where you're getting your materials, and second, have an understanding of some of these materials, like clopyralid is not registered for residential use. So when I get my municipal grass waste, I know that nobody's using or should be using a product that is persistent. So clopyralid, Roundup, it's not so much a concern because I know that it's going to break down in my composting process. It's also going to break down through microbial processes. Microbes are releasing enzymes that these molecules like Roundup, glyphosate, they're very large molecules, and any break in that molecule chain is now a different molecule. It's no longer the active ingredient, and you don't have to be concerned with it. So how do you do these tests? To just basic at-home tests. I've done them here before, and it's very easy. You could certainly send your product in for lab sample. There's only so many labs in the country that can test for these chemicals, and they're quite costly. But what you would do is have a 50% mix of either soil, potting media, whatever, of your compost, and your compost and some media, and then you try to go, I think red clover is one of the preferred ones, any clover, but some broadleaf seed. The clover shows symptoms, it's very sensitive. So if you're seeing symptoms like yellowing, leaf curling, dieback, that could be a result of the um, the persistent herbicide. We have a question here. There is other experience with glyphosate retention in the environment. Is it possible? It depends the application. I'm not quite sure the application of how it's applied. Yeah, glyphosate you will have it, it will survive in the environment, but it's not long term. Yeah, it's rare that it could go through the time of the composting process. So it's less of a concern compared to some of these, what we consider persistent herbicides, because they last years. Chat function. Do any of you do you have any research on wood ash biochar usage? I do have a small amount of research on biochar usage. It's mostly from my graduate career in doing plant disease studies, and I kind of got out of it just because it was not well known of a material. It wasn't well defined. I still don't think they have defined biochar very well. Just like composting, your starting materials can influence your final result. So whether it's biochar with wood, paper pulp, the process of how you actually generate the biochar, the temperatures that you're held at. What I can say is it doesn't take much. It's very small amounts of biochar to actually make a big influence or make a big change. And it's just a small rate is what I saw, where you start to see changes in plant production.
Rick, can I interrupt you for a minute on that
Sure.
too? That's also a great question to ask Debbie, because Debbie did all of her graduate work on biochar and a lot of research. So she could probably add to that too, if you would like further elaboration.
Good. Thanks. Herbicides. Yeah, so am I concerned about herbicides and pesticides? I certainly am. I don't accept horse manure. I've had a lot of people ask. I do test my finished grass compost, and a lot of my compost is being used in the field, large scale applications. So if there is a concern, which I monitor, I know it's diluted a lot more when I'm putting into the environment. Emerging contaminants, PFAS. Again, it's a concern of these chemicals, like the plastics. I'll admit, my biggest strain in my compost operation, because I'm getting leaves, is the plastic contamination. And I measure that too. It's not something I highlighted here, but it's always less than 1% by volume or weight, but it's more unsightly than anything. And if I'm trying to sell a product, I think only about 10% of my material is sold to the public, and that's only because we don't have a screener. If I had a screener, I'd be able to get rid of it, and I don't have a screener. So trash is always a constant bane of my compost operation. The environment, the positive notification. Where is it applied? We have seen much longer retention in the environment and in humans. I think I would refer to an article when it comes to persistent herbicides. There's two great review articles by Bob Rink, Rink et al. And the year of it, I think it's closer to 2009. So it's in the 2000s. He has two articles on that, and there is a table in there. I probably should have showed that now that I'm mentioning it. There's a table showing the chemical half-life of these materials, and one was showed glyphosate and showed a lot of the DDT. It showed these things, and that's where I'm drawing a lot of my experience with is that table, knowing that just the actual molecule will break down by itself in a certain time period. It also showed that certain molecules will break down faster through UV radiation. So that does happen as well.
Rick, there's another question in chat that a little bit further up from Al, where he says, how do you add nitrogen if you have to use urea or nitrogen-rich fertilizer to start up or heat up the pile?
Okay, good question. You could think of this in two ways. If you're trying to make the best compost in the world, you're picking and choosing your materials, your feedstocks, or you could think of it as just managing waste. You use what you have, and so if I was making just leaf compost, I know a massive pile of leaves is going to heat up by itself. I have several piles like that now, and they're well above 130 degrees this time of year. But these are 7 feet high piles, and basically maxing out my my compost turner. So my compost turner is 7 feet tall, 10 feet wide, and I'm making piles that are that wide and tall, and it's going to be breaking down. So the piles are going to heat up themselves. Whenever you put organic matter of a high volume together, microbes are going to be doing all that activity. They're going to be breaking down. It's going to be heating up. If you need to add nitrogen to your pile, you're looking for other sources, vegetable waste. I wouldn't add urea. It's costly. I mean, if we're talking about just the actual product of urea, because we do that for conventional ag, where we side dress with urea, it's very costly. Other nitrogenous sources, manures, your grass, if you could find it. I get all these municipal waste for free. I intercept them before they go to the landfill. Then municipalities, they don't have the capacity to process them. So before it goes to the landfill, they find locations to dump because it's going to be cheaper. And so I get it for free. I don't charge them, they don't charge me, and I can make calls. So I call them anytime. Hey, I need some of these materials, because it's a waste product in the municipality. So grass is one source for nitrogen. Food waste, I get calls all the time for, hey, can we deliver food waste? I don't permit that, just because the amount of contamination that is associated with plastic contamination that's associated with food waste. But we do food waste composting here on site. So the food waste is always available. You can source restaurants, schools, they always want to try to put that into university level, down to elementary. There's always that access. It's just it needs, when you get into food waste, it requires a lot more control than your debris.
Rick, you had mentioned an EPA presentation. This is Mina, by the way. Testing of persistent, what was it, chemicals or herbicides? Can you just say that one more time? Because I want to try and find it so I can share it in the follow-up email.
Yes, it's Bob Rink, and it was he has okay, I'm sorry. Bob Rink has an article on persistent herbicides. So yeah, you could share that, and after this I could send that to you, the actual article.
Okay, great.
Yeah, I have no problem doing that. So that's a nice literature review on the subject. So it's not a study where they were looking into it, but they were it's a review of all the studies before then, and that's just the subject of persistent herbicides in compost. It's a great review article. It's a 2-part series, and it will get technical near the end. But the actual testing, there's not one, good. Well, there are many people that have already discovered these at-home testings for persistent herbicides. but there's no, I haven't seen a nice article that says do it this way. But the US Composting Council does have a webinar on just testing for persistent herbicides that's coming up. That I encourage people to view if they can. But it is basically what I had said. You can do this at home. The 50-50 mix of your material and some potting media and clover so far, at least years ago when we were first people were first discussing it, clover was the most sensitive to herbicides.
Now, regarding that bioassay, how do you know, like, do you always couple that with having the nutrient analysis? Because say it's just, I don't know, high salts or some sort of heavy metal, how you don't really know, right? If it's an herbicide or if it's some other imbalance in the compost, unless you have that analysis.
Yes, and that I didn't highlight that in my bioassays, but when you saw sand or potting media, that was the control. Compost. So you're always comparing it. I'm glad you brought that up. You have to compare it to a control. So if you're doing your any bioassay, whether it's for knowing how much you need or if it's for a persistent herbicide, you have to compare it against your negative control, something you know doesn't have it. So it's going to be without your compost, and that's what you're controlling it to. And if it's going to be, maybe it could be the salts or an herbicide damage. I don't know if I wouldn't take in. I've just done it for so long that I know how my compost is going to respond, but I wouldn't look at my chemical analysis to say how it's going to perform in the field. It just doesn't work like that. And there's too many variables and too many different plants. So it's not always going to be a one-to-one. It's more of a peace of mind that's saying, okay, this is total nitrogen, or this is my soluble salt content, but your bioassay and how much you need, that's going to be more telling. Let the plant tell you how it's going to respond and the quality of your compost. Because, you know, when we say quality of compost, I could ask anybody, they say, I have great compost. Well, what does that mean? It's only a function of its use. Compost could be used as a mulch, and its function should be to stop plants from growing, prevent weeds from coming up. But if it's used as a soil amendment, we want plants to grow. So it's a measure, quality is a measure of its function in its use. And when it comes to these bioassays, I'm trying to measure, are my plants growing bigger? Are they healthier plants? Is my soil healthier? And that's where that's, the compost amendment bioassay is really going to tell you all that information. And I do the chemical analysis. I have an ongoing project just to see the nutrient dynamics in compost piles with different feedstocks, different ratios. That's just the chemical analysis is very accurate, and it tells a story. And once I'm finished, that one review that I showed there, that was, that's 10 years almost of just a lot of compost sampling.
Rick, I have a follow-up question on that. You mentioned, the compost is particular based on usage. Like, is it good at its purpose? When you have all of these different compost piles, like at Rodale, you kind of have the luxury of having one that's maybe more manure-based, one that's more processed veg. Like, you have all these different piles. Do you, in your mind, know which compost is best for which application? Because you've been doing this for so long, working with the farmers.
I have an idea, and that's based off of the visuals that I tried to highlight here, is that I can see some piles are going to be have a better water holding capacity. I'll just take the extremes. Taking just leaf compost, it's a lot of carbon. So I know it's going to be lower on the nitrogen side. It's going to be lower on the nutrient side chemically. And it's not going to have, it's not going to be as robust. So if I want a potting media, we take our potting media here and we amend it to 40% with compost. And if I'm going to take a potting media, I'm going to want something that's not as fluffy as leaf compost, something a little more dense. You can see it has a greater water holding capacity. It's just the moisture and compaction. It's kind of your senses. What does it look like? What does it feel like? So I could tell that certain piles are going to have different properties.
Okay, thank you. And people, if they have any more questions, can submit them in Q&A or chat. And we're going to have Debbie start her presentation at 11:15. So any follow-up questions for Rick, just direct them to him now. And then maybe we'll go on break until 11:15. Everyone can have like a 5-ish minute break, use the restroom, get some tea, whatever. If you have questions for Rick, submit them now. Okay.
Yeah, I'll stay on. So if anything comes up in the chat, I'll respond and yeah, enjoy Debbie's talk. Should be good.
Hey,
Thank you
Rick, I
so
do
much,
have,
Rick.
oh, sorry. Yeah, thanks, Rick. I do have a question just because, you have so much experience with compost systems. At Rodale, you mostly use, what is that called? The windrow system?
Yeah, windrow turning system.
Do you have experience with other systems? And do you find that you prefer the windrow system or it's just what works at Rodale?
I'll be perfectly honest, it's just the tools I have. So I do have experience with other stuff. Most of it is in the turning systems, but I have a compost turner, so it works really well. Before that, I was using a bucket loader to manage large amounts of material, and that's what Rodale had done. Before that, it was a pitchfork. So I've done static piles before. In my backyard, I consider it a static pile. Large scale, I've done static piles. You just let it sit and it's going to break down eventually. I'm well aware of static aerated piles where you're doing forced aeration. I've never operated a facility using that technology before. The only thing I could say is it's much more technical and you have to dial in how much aeration and the timing of aeration. And your feedstocks can't be diverse. So you're always using a recipe when it comes to static aerated piles. There's some flexibility, of course, but in my operation, my feedstocks change from each month. Right now we're doing plant cuttings. So I have a lot of landscaping debris from trimming back. And then it's going to be, green waste, lettuce waste and stuff. And then it's going to turn into tomatoes. So windrow turning system gives you greater room for error, I would say.
All right. You may have said this at the beginning of your presentation, but just as a reminder, can you tell us again the length of your composting system, like from beginning to finished product?
So it's in agriculture. There's no incentive for me to make compost fast. If I finish a compost pile and let it sit, it's going to grow weeds. It doesn't discriminate because something is going to blow in or it's just going to come in somehow. But it's weed free when it's finished. But if it sits for 6 months, weeds are going to start growing out of it. So my process, I've made compost in 4 months. That was the quickest, but it's usually if I make it in the spring, it's ready in the fall. If I make it in the fall, it's ready in the spring. So we're only applying compost in just, from a practical standpoint, you're applying it either in the spring or the fall. If I was a commercial operation and I had to move product, I'd be composting more aggressively, turning when it's very appropriate and monitoring temperatures. But I don't have to do that in agriculture.
Okay. All right. That makes sense. All right. Okay. Well, thanks again, Rick, for extending your talk and making up for Shama not being available. We really appreciate it.
Yeah, it's good. Thanks for all the questions too.
Yeah, that was great. I like how you just, gracefully incorporated the questions that were coming in through chat. That was
Yeah,
helpful.
breaks up the talk.
Yeah. All right, so we'll get started again at 11:15. Debbie, if you want to go ahead and just share your presentation, so then Emily will just introduce you at 11:15.
Okay, everyone, welcome back. It is 11:15, so we're going to get started with Debbie's presentation. So Debbie Aller is an extension associate who works with the New York Soil Health Initiative with Cornell University, and I am very excited to hear your presentation, Debbie, on compost analyses and interpretation. Thank you.
Great, thanks so much, Emily, for the introduction, and to you and Nina for inviting me to participate in your webinar series on compost production. I think it's really great. It's a really important topic, obviously, and there are lots of questions and interest in it in general. So I apologize. I literally came off a 1-hour presentation right before this, so my mind is a little crazy, and I've had a lot of coffee today, but hopefully I'll be able to provide you some insights into some analysis and interpretation of compost results, and then answer any questions that you might have, and please feel free to put your questions in the Q&A or chat as well while I'm speaking if questions come up. But hopefully I can clarify, because I know I'm the last speaker in a 4-part series, so I think this is great. And I do want to mention it's nice to see some very familiar names on participating in this webinar. I like being still connecting with everyone from Long Island, even though I'm not directly located there anymore. So moving right into composting and compost, I know this has already been defined in the previous webinars and by previous speakers and Rick's presentation on some on-farm composting. So thinking about composting versus compost and the overall process of it as controlled decomposition of organic matter that's occurring outside of the soil environment. So there's decomposition happening all the time within the soil, but with composting, right, we're speeding up this process. We're providing adequate moisture. We're heating this compost. There's a lot of microbial activity, and all of these, let's say, activities and processes lead to various products at the end, which we all call compost, right? And so compost is not a fertilizer, although it can be considered kind of a dilute source of nutrients for the soil, but it really is a soil amendment. And it's helping build soil organic matter, which then we know has profound impacts on overall soil processes and soil functioning. So as a soil scientist, compost is a great resource and really important for farmers, for homeowners, for anyone looking to improve their soil, have better plant health, greater crop yields, and things like that. So there are various compost methods, which I know have been spoken about here. But I do want to mention just these four major ones, and we can think about that and the importance or these different methods. And then when we think about a compost report and what we need in terms of when we are analyzing compost and how we interpret the compost reports for certain end uses, these kind of go back to these initial methods and the products that come out of these. And the materials that are going into these different composting methods. I know Jean had spoken about animal carcasses and animal mortality and its role in compost. And then there's also, right, the compost production that's coming directly from food waste or more crop residues or leaf material and mulching materials. And so all those feedstocks and inputs into those initial at the initial composting process will impact that end result and the quality of the compost. And so compost production, 4 main stages. Some people think we'll talk about 3. I like to think about it as 4 or even more, but the mesophilic, thermophilic, cooling, and curing phase. And these are all important stages within the compost process. And particularly this thermophilic stage, which is critical when we think of for our farms and breaking down pathogens and weed seeds. So we're not dispersing those on our farms when we're applying compost, and the presence or absence of weed seeds and pathogens is important when we think about compost quality and the impacts it has to the soil in the short term as well in the long term. And then this cooling and curing phase, and thinking about maturity and stability, which I'm going to get into in a couple slides. So I'm sure probably someone already showed this figure about compost production, and thinking of our initial, grab this laser pointer. These are initial starting materials, our sources of nitrogen, and our sources of carbon that then are subsequently degraded further and further into what we consider a finished compost product. And so here, during our initial kind of mixing of our organic amendments, that mesophilic phase, our thermophilic phase, when we're reaching and have that stability of a high temperature in the production, and that curing, cooling, and then kind of all the way into more maturity of that compost and it being ready to apply to fields and landscapes and in other areas. So I think it's important to differentiate between compost maturity and stability, because these are 2 different things. They are not the same. And so maturity is a subjective classification that is describing the suitability of compost for a specific purpose, for a particular end use. Are we thinking about utilizing compost within horticultural mixes, or are we thinking about larger scale field applications to agronomic crops or diversified vegetable systems, things like that? And so immature composts can contain volatile organic acids or ammonia, and these can be have a really detrimental effect on young plants, and this is why germination tests, which I'm going to talk about, are often used as an indicator of compost maturity, because if there's an issue with plant germination, in the case of something as simple as like a faba bean, this may have detrimental impacts for when we think of larger scale field applications. So it's important that the compost has reached a certain maturity level before we're thinking about its use in various applications. And so laboratories typically assign what they call maturity ratings, because as an organic material, it's continuing to break down. Compost, even though it's mature or finished, hasn't stopped necessarily degrading, because this is carbon that's still being consumed by microorganisms and entering the carbon cycle and other cycles within the soil. And so moving from maturity to stability and what that is. And so stability is really the resistance of that compost material to further biological decomposition. So obviously, like I just mentioned, there's going to be some sort of fraction that will continue to degrade and be consumed and utilized as food by microorganisms, but the majority is stabilized. And so this is really important when we're thinking about applications for potting mixes, for horticultural medias, and bagged compost. And stability might be less important for field applications. Of course, compost really needs to reach a certain stability, even for field applications, so we don't have those impacts to young plants or germinating plants. But its importance is not as critical as for potting medias, particularly when we think about if we're applying compost, incorporating into a field, and then not planting our crop for a couple weeks. We're giving it some time to even further degrade and mature within the soil system. And so the way stability is typically measured and indicated in the lab is through compost respiration tests, and measuring within an incubation time commonly over a 3-day period, how much of that carbon is respired, similar to kind of a soil microbial respiration test. And so I do want to mention that the US Composting Council, which is a leading composting organization across the US, rates compost maturity typically by 3 categories: the very mature compost, and immature compost. So very mature compost are composts that have been well cured, and they have a little decomposition rate, and they're of high quality. There's no odors associated with them, and there's no toxicity when being used in germination tests. And then that mature compost, they're of high enough quality to be marketed, but they're not cured as much as very mature composts, and they may be decomposing still and be a little less stable than those very mature composts. And then the immature composts are not stable yet. They're still actively decomposing and really are not ready to be marketed. So I want to go into how we can tell if compost is mature and finished, and if it's ready for use in various applications. And I know Rick talked about this from a field side of things and actual on-farm production. So I'm going to initially just talk about some of these visual indicators and kind of in-field, and then really go deeper into the laboratory analysis and interpreting the results. So I really always like to emphasize for folks that are producing compost or receive compost is to use your senses. I think these are the cheapest things and the best things that we all have available to us. Smell it, look at it, feel it. Is it a darkened color? Can you not tell what the starting materials were? Being unrecognizable. I mean, to some extent, you can tell, are there, some woody materials in it, but you shouldn't be able to see any trash. You really shouldn't be able to tell that there was food waste within there or anything else. It should have a nice earthy smell and it should be moist, but it should not be saturated. So I encourage anyone, whether you're purchasing compost or you're making your own compost, to really get used to looking at it and feeling it. And just utilizing your senses to get a sense of, does this look right? If it smells bad, maybe there's an issue. And so these are just some images of what unfinished compost may look like in various settings. In the top here, we have a compost pile where there's still a lot of garbage. There's a lot of materials there. And this was compost that was being marketed. So this is compost that still really needed to go through a sieving process before it should have been sold or would be sold by this producer. So this is something where we have a lot of inert materials. We have glass, we have plastic present in that compost. And we don't really want to apply that to our fields because then we're just going to be adding garbage there. On the bottom here, the pile is still actively in the thermophilic stage. It's still steaming. It is not cooled, it's not cured, and it's certainly not mature and ready for use. And similar with this pile over here, it might be more difficult to see. When actually I was with Mina on this visit, we were looking at this pile. It was still hot. There was still steam coming off of it. And really, you can't tell during a presentation, but it was saturated and it smelled really bad. And so it was encouraging this grower to not apply this to this field because there could have been potentially issues from toxicity. So thinking about maturity and stability, it really brings us to compost quality and what we mean by compost quality and high quality compost, whether you're purchasing it or you're making it yourself. And this is the chemical and physical makeup of a compost product. It includes many different properties, whether these be chemical, physical, or biological. And so high quality compost is compost that's free of weed seeds, pathogens, and some of those inert materials that I mentioned previously. And what's important about high quality compost or compost production in general is that because it's an organic material and different feedstocks go into it, within a pile, if you're producing it yourself or you're purchasing it from a compost producer, that the quality can vary between batches and between deliveries, even from the same compost producer. So it's important to be getting high quality compost before we're thinking about spreading it on our fields or using it for horticultural applications. So now moving into compost testing and why we need to do compost testing and why it's important, and then what are some of the results we're getting from these tests, is that we need to characterize the beneficial physical and chemical properties of compost and identify potential problems with the compost before applying it to fields. If you're looking to get compost certification, like the US Composting Council certified compost with the seal of testing assurance, which I'm going to mention in a little bit more detail soon, you need to test your compost to get that certification. When we think about product standards, testing compost and having results both as a producer of compost and as a potential end user of compost, it provides valuable information for both. For consumers, it allows them to know what's in this material. What am I putting on my fields? What am I using on my landscape or in my gardens? Just knowing what you're aware of. I think it's a similar thing when someone's buying a fertilizer product. Know what's the composition or makeup of that fertilizer product. How much nitrogen am I adding to my soil? How much potassium am I adding? Just like that fertilizer, compost is similar. Knowing, is it of high quality? Is this something I want to be adding to my fields? And for a producer of compost, it allows them to identify potential issues during the composting process. And if changes can be made during the compost production, are there management changes that could occur to meet or produce a more desirable product for their end user? And so it allows for monitoring of changes during the compost production before you create a finished compost product. And it helps producers address customer questions or complaints they may have with your product. So by being able to show customers the results of a compost test can be really important to verify you are producing a high quality product and you want people to buy it. The U.S. Composting Council had developed this test method for the examination of composting and compost. And this is standardized methodology for testing compost. And there are certified labs that participate to get the seal of testing assurance. So a producer knows they are making a good product and the consumer knows they are buying a good product. And so these STA are certified labs by the U.S. Composting Council and this program. There are no certified labs in New York State. Actually, the closest one to all of us is at Penn State University. And then there's some others spread across the country. But this really is a verification and a standardization process for producers of compost here. So when to when to test your compost, it's best to do it often and do it regularly. So you can better understand this product, which as an organic material is continuing to break down and to change. And so characteristics of a compost change over time. So testing a compost when you're producing a new batch of it, or when you're changing the raw materials going into that batch of compost, it's important to test the material to get a sense of what are its properties, what am I marketing, what can consumers or customers expect from my product. And here are some kind of limits. These are quite large productions from manufacturers for if you're producing over 17,000 wet tons per year, kind of the frequency of testing. And these are suggestions from the U.S. Composting Council. So how to test and when should you test? So sampling, obviously, similar to soil testing. If you're a farmer, you want a representative sample of that compost pile. You don't want to just take a sample from the surface. But you want to get into the pile, you want to take from multiple areas of the pile to make sure you're taking many different subsamples to create a single composite sample that represents the compost you are producing. And so it's recommended that obviously depending on the size of your compost production, 2 composite samples are submitted to a lab so you can see, is there a lot of variability? Or am I coming to a common conclusion within my analyses? And then the timing of when you submit a sample to the lab really depends on the purpose of the end use of that compost. If you're a producer, like I mentioned previously, it could allow for modifications during the composting process. Do I need more carbon? Do I need more nitrogen? Do I need more moisture? Have I not reached my highest temperature there? Is it finished? Is it not finished? And then at the end of the production of the batch of compost, this allows for that standardization, for better marketing. So testing when you feel your compost is mature, when it's that finished product. So how do you choose a lab? And what makes sense in terms of the analytical packages you're looking for. So similar with soil testing, with compost testing, I always recommend select the lab and stick with it. Different labs use different methodologies for analysis, offer different packages. And so if you start getting analysis 1 year from one lab and another lab another year, they're not necessarily comparable. They might not be using the same methodology. And certainly if they're not part of the US Composting Council certified laboratories, they aren't using a standardized practice potentially. So I encourage you to select a lab and stick with that lab for your testing so you can compare your test results. Here's an example of just a few labs that offer composting testing, and some of, let's say the differences in pricing, the differences in analysis that are given within a different package. So there are many tests out there. There are many analysis that can be done. So I think it's important to work with Extension, work with folks to get a recommendation of what is a reliable or good lab when it comes to compost analysis. And also to make sure that that analysis meets what you're looking for. And so it's important, contact the lab before submitting a sample and figure out what package do you want? What do you need? What makes sense for the message you're trying to communicate if you are a producer? And figure out how do I go about collecting my sample and submitting that properly to the lab to get the best analysis from them. And so you can also request an example of a report from a lab and to get a sense of also the interpretations that may come with that report and figure out, are these the results I am looking for? And so here's an example from Woods End Lab. I just took a random laboratory and shows you they offer more than 5 different composting analysis packages. These come at different costs, from a simple maturity test at $25 to a premium package, which is over $600. So you can call them, you can talk with them, you can figure out, do I need a $600 compost analysis? Or can I just do a simple maturity test? Can I just do carbon and nitrogen and some nutrient values? So there are many different analyses out there and offered by various labs. So what to test for? What are some things to think about? There are many different parameters for testing of compost. I've listed here just some ones that are commonly found on a compost report, which I'm going to go into more detail in my next slide. Things like organic matter content. What are my percent solids and moistures? My water holding capacity, carbon to nitrogen ratio, which is a big one. And then there are many different tests, these add-on tests that are available. Do I have concerns with heavy metals or pesticides or germination? I know there's a lot of talk and a lot of interest in microbial populations nowadays. And do I want to pay for additional microbial testing? To figure out what's the biology, the fungi, the actinomycetes that are in my compost and could potentially have an impact for whatever intended end use of that compost is. There's a really great fact sheet that on the Cornell Waste Management Institute site that gives you a compost parameter and describes what that parameter means, with some typical ranges for compost that are produced by dairy manure-based compost and poultry manure. But you can get a sense of what each of these parameters means just within this table. So I've listed that here, and if you go to the waste management website, you can find more information. So now I think I know I'm meant to be ending in a couple of minutes, but I'm really gonna spend that time getting into how we go about looking at a compost report and interpreting one. I know Mina and Emily had shared an article I wrote in Agricultural News that really laid out what I'm about to present now. So hopefully that can be a reference material for many folks, and they were able to share it or will soon if they haven't already. So here's an example of a compost analysis report from Brookside Laboratories, which is a laboratory in Ohio. It is not I don't believe it's a certified US Composting Council laboratory, but I think they do provide a lot of the information needed to interpret compost and get a sense of what is in that material, and is it ready for field application or use within horticultural medias. So first thing to look at and to think about is that moisture, typically given on a wet basis as percent moisture. And so you can think of percent moisture on a compost report inverse to percent solids. So if you have 40% moisture, you're going to have 60% solids. While ranges vary, I've typically seen that between about 40 to 60% moisture of a finished compost material is good, is adequate. That's a good range. It does vary a little bit, but you don't want a material that's saturated, that's really, really wet, and you don't want a material that's really dry. So you want some moisture in there, and obviously you want solids as well. Loss on ignition. This is a method that is used to quantify organic matter. There's basically the same procedure used to quantify organic matter in soils. So within a finished compost, once again, this range between 40 and 60 is good. You know, as I've mentioned, and I'm sure as you've heard throughout this series, that because compost varies, we're not going to be able to hone in on a specific number. There is variability in this product. Total nitrogen. I think it's important to recognize, as I mentioned previously, that compost is not going to replace a farmer's fertility, but it's an additional source of fertilizer. It's also a source of some micronutrients as well, but it's not a significant source of nitrogen. So typically between 1 to 5% on a compost report is good. And I wrote somewhere that, okay, so if a compost contains 2% of nitrogen on a dry weight basis, a dry ton of that compost would supply 40% of that nutrient. So in this case, we have 2% nitrogen. This compost would, a dry ton of this compost would provide 40 pounds of nitrogen. Composts don't typically look much or spend time on the phosphorus potassium side of things. It's not typically a significant source of that. Unless, of course, you are using, let's say, a dairy manure-based compost, you're going to have higher phosphorus coming from that source. So it does obviously depend on that starting feedstocks that go into that compost production. Another thing to look at, percent carbon. How much carbon are we adding to the soil? How much is entering the organic matter pool within our soil and the carbon cycle? There, from a pH standpoint, it's a wide range between 5 to 8%. Sorry, not percent, 5 to 8.5 on the pH scale is perfectly fine for finished composts. You obviously don't want a very acidic compost, and you don't want a very basic compost. We all know that plants are optimum within that 6 to 7 pH range, or let's say the majority of plants grow best within that range, and nutrient availability is the highest during that pH range. So if we're applying an amendment, can we keep it also within that neutral range is good. And then a lot of people think, and what is an important indicator of maturity is the carbon to nitrogen ratio, or that C to N ratio. And so this is often used to indicate compost stability and also nitrogen availability. A compost that has a high carbon to nitrogen ratio, and we're talking about 30 to 1, so 30 parts carbon to 1 nitrogen, means that nitrogen mobilization or tie-up of nitrogen may occur, and that nitrogen won't be available for plant use. So the microbes within the soil are consuming that nitrogen, and it's not in a form that's available for plants to take up. On the flip side, if we have a low carbon to nitrogen ratio, so we're talking about less than 20 to 1, that there is nitrogen mineralization, and that N is becoming available for plants to take up, and that's what we want, right? So there's a very wide range. I would say there's flexibility within this, maybe 10 to 1, or between 10 to 1 to 25 to 1 is kind of optimum when we think about carbon to nitrogen ratio in a finished compost. So just realize you don't want something that's super low, and you don't want something that's super high, because it really does have potentially, depending on application rates, significant impacts on nutrient cycling within the soil. I do want to mention, particularly if anyone here is utilizing compost within potting mixes or horticultural applications, that electrical conductivity or measure of soluble salts is important. Not all compost analysis provide electrical conductivity. So specifically, if you're using compost for horticultural applications, I recommend getting a measure of electrical conductivity, and it really should be less than 4 millimoles per liter as one indicator there. So the last thing I want to touch upon here are some additional tests available for compost. I've listed 6 here. There are other tests available as well. And it really, once again, depends on what is your intended end use of that compost material. So particle size is more important for horticultural applications when you're combining it within a potting mix compared to field applications. We can think about having larger particle sizes of compost for field uses. This calcium carbonate equivalent, or CCE, is related to lime, and agricultural limes, right, are used to adjust soil pH and raise soil pH from being more acidic to a more neutral value to improve the availability and uptakes of nutrients to plants. So it's important to think about the calcium carbonate equivalent if you are trying to adjust the pH of your soil to raise the pH of acidic soils, because it can replace some of that agricultural lime that is being used by a farmer. Additional tests you can ask for are seed germination tests, or these are bioassay tests, and there's basically like a fava bean might be grown in compost and no compost, and see how well that bean germinates. And this can help give some type of indication about the maturity of whether that compost is cured. Can it be ready for application, or be ready to be marketed, or it's not ready yet? It's somehow potentially stunting a plant or inhibiting germination. And this can give some indication of, is there ammonia present, or are there still high salts within this compost? So that can be important. And also, if you're a farmer or homeowner, this is something you can do yourself with just some little containers and putting some soil in some compost in some, or maybe some different mixtures of compost or different rates of compost with that soil, and seeing, do beans or peas or something germinate okay, and is it not stunted? Is the root morphology looking okay as well? Herbicide bioassay tests. Obviously, herbicides are becoming of a lot more concern for end users of compost, specifically those purchasing it, a lot of people are concerned about the impacts of herbicides on soil biology and also, entering drinking water and affecting humans as well. So there are plant growth tests that are used to evaluate potential plant injury due to persistent herbicide presence. However, these bioassay tests don't quantify herbicide concentrations. So there are targeted herbicide tests that can quantify those, but they are largely very expensive and might be difficult to capture within a compost analysis. There are tests there for inerts that I mentioned before of plastics, glass, metals, and other contaminants in compost. And so you really only want to, you don't even want to trace basically of inerts within compost. So if you are receiving compost or making compost where you're seeing essentially garbage, that is not good. You don't want that. And inerts become more and more apparent within a compost pile as the organic materials break down, right? The portion of materials that are unable to break down increase compared to the organic materials that are broken down by microorganisms. And the last one there is microbial analysis. These are becoming a lot more interest. There's more research going into different, let's say, in-field microbial analysis as well as laboratory ones to kind of quantify the populations of fungi, bacteria, and other microbial indicators in the soil, in the compost. But we know microbes, right? They're alive. So populations fluctuate a lot based on temperature, based on moisture, based on season. So microbial levels within compost piles are very variable, and their presence may be only there for a short period of time. And this is also important when we think about compost teas, for example. Many people are interested in compost teas, and we need to make sure we keep the life there. We create conditions that are favorable for microbial populations to thrive. So for many applications, some of these microbial analysis are very limited, but we have a much greater capabilities for sequencing and quantifying microbial populations in compost and soils as well. So I know I'm way over time, but there's a lot to talk about there. And so just some key take-home messages for everyone here when it comes to thinking about analyses and interpreting compost reports is that you really want to select a laboratory that works for you and stick with that laboratory, and recognizing that there are different approaches to analyze compost and different methods used. And it's important to think about compost analysis when you're thinking about what are you planning to use that compost for, or how are you trying to market your compost material? What analysis are relevant for your needs? If you're a farmer, are you looking to, use it for adding your increasing your organic matter in your soil, or adjust your pH? So these are things to think about. You obviously, when you're submitting samples, want to submit a representative sample of your compost pile and submit them when you finish creating a batch or when you're adjusting what raw materials or raw feedstocks are going into that compost production. There are a host of additional tests. I mentioned a few that are available at commercial labs. And some of these may be useful, but once again, it really depends on what is your end purpose with this compost. And that if you're a consumer and you're purchasing compost from a supplier, I always encourage folks, ask for a compost analysis. If someone is selling a product, they should have an analysis available to show you, to make sure they're selling a high quality material that's worth the money you're giving them. And if you need help in interpreting those results, obviously I provided a very quick overview of some important indicators to look at and some ranges, but Cornell Extension, other technical service providers are available to help with interpreting reports and to think about what are the most important aspects of that compost material and how you want to use it. So resources are available. There are also a lot of resources online. And yeah, I'm going to leave it at that. And so I'll say thanks for listening. Hopefully you learned something here and I didn't repeat what other presenters had said before me in this series. And if there are any questions, I'd be happy to take them. I know we're finishing up in a couple minutes, so feel free to send me an email if you do have any questions at a later time. So thanks again, Emily and Mina, for the invitation.
And thank you, Debbie. That was excellent. I'm so happy we got to have you speak here. I know I put a question in chat for you and others. Please feel free to, and we have the last 3 minutes here. And then just to make sure that I have everyone's attention before everyone logs off, thank you so much, everyone, for attending this webinar series. Mina and I will email you all of the follow-up resources, and you can direct questions to the presenters or us. And now Debbie can answer some questions. Thanks, Debbie.
Yeah, thanks, Emily. So that's a really good question. And so I think, yes, I would say, just like I mentioned with the calcium carbonate equivalent in that lime factor, if you're adding some type of amendment that's going to impact pH or impact nutrients, you want to account for that in your fertility program. So you might be applying some compost and providing some nitrogen that then you can cut back on your potentially synthetic fertilizer inputs, or you can cut back on how much lime you need because you're accounting for that in your compost additions. So yes, it depends on how much, but I think that's why getting the results of those analyses are important.
All right, Debbie, it looks like you have a question in the Q&A. If you want to go ahead and open it and just read the question aloud, that'd be great.
Oh, that's such a great question. Do you have any thoughts on this trendy use of biochar instead of locally produced compost? That's going to open a whole nother can of worms, Naomi. So I think, well, Emily and Mina know I can talk about biochar for hours. And so there's a role for both of them to play. I think, and one of the important things to think about with biochar applications and biochar in general is that biochar is that backbone or that carrier of nutrients, and it's that long-term source of soil amendment. So biochar really should be inoculated or combined with some type of higher fertility source, whether it be manure or compost, to get that more labile and readily available nutrients and carbon from compost and those more longer-term soil improvements from biochar. So they play two different roles, and they can be used in combination and should be used in combination. I have many more points on biochar, so if you do have specific questions, I'm happy to share presentations I've given on that and more details. So please follow up with me on that. But that's a very hot topic at the moment.
Debbie, I'm going to put you on the spot with that for a little bit longer if I can. This
Sure,
has more to do.
I'm here all day.
I am switching from, compost production to compost use slash, soil conditioning. So with biochar, I forget who it was now earlier in this series, they mentioned that you could use biochar to improve like porosity and structure, right? So do you think it's better to use a coarser biochar combined with compost if you want to improve the porosity and structure of soil?
Yes, so it's a good question because particle size of biochar materials, there's a lot of interest in it right now. And part of it has to do with how rapidly that biochar would break down, whether it's a finer particle size biochar versus a larger size. So for many soil applications, if you're not kind of top dressing or using it within like kind of a liquid slurry, a larger fraction of biochar or particle size is typically a bit better. Or if you're applying it in compost, let's say. And I do want to mention, actually, that reminds me that there's a fact sheet. I should send this along to you to pass along to participants, that there's a lot of benefit to actually mixing biochar in at the beginning of the composting process. If you mix about 5 to 10% of biochar into compost production, it actually helps speed up the degradation rate of compost. And so this was a fact sheet that was put together by the US Biochar Initiative and the US Forest Service. And there's some really great information about biochar use in compost production. But yeah, particle size, there's a lot of, I think, still uncertainties around that, Mina.
Okay.
And it really also depends kind of on the feedstock too.
And are people adding biochar just in general to their compost production because of odor concerns? Like, would it help with odor concerns?
100%.
Okay.
It is known to reduce odors. When it's there's interest in using it within manure lagoons, let's say, to cut back on odors. It captures a lot of greenhouse gas emissions, whether it's manure production or compost production. So there's a lot of benefits by adding biochar to compost. And it also, if you have a very wet compost pile, biochar can help kind of capture and retain some of that moisture as well. And then capture some of those nutrients within the compost and then act as like a slow release fertilizer over time. And so one of the most important things when we think about biochar applications comes to the fact of not applying freshly produced or raw biochar into fields. It needs to be inoculated, it needs to be charged around that. I'm quickly going to get into a biochar presentation.
I know, I'm sorry. It's really fascinating. I wish we had included it in the series, but like it didn't even come to mind. But yeah, any articles you want to share on that, please send them our way and we'll include it in the resources folder.
Yeah. Yeah, I'll share that one of biochar use in compost. And also I'll share a resource page that I just created on the New York Soil Health website, all about biochar, about sources of biochar, which I see there's a question in the chat right now about where you get it. And then how you make biochar, different applications, and there's a host of videos and resources and links to other reliable sources of biochar information. So I'll make sure to share both of those with you to share with participants. And do you add 1-to-1 addition of biochar with leaves or wood chips? No, it's not a 1-to-1 ratio. And so if you're adding biochar to compost, the research has shown really a benefit within that compost production. If you add 5 to 10% by volume, so whatever your volume is of your compost pile, if you supplement or add about 10% biochar to that, we're seeing positive improvements in the compost production.
And then there's a question in the Q&A as well.
But how will the compost be used and what would be the resulting pH? What if you are using it with shrubs and trees rather than agricultural products? Okay. Yeah. So biochar is a very diverse material. It really depends on the feedstock and the production conditions that are used to make it. So that feedstock, what I mean, is the same as compost. So what's that raw starting material? Is it made from leaves? Is it made from wood chips? Is it made from manure? And so that does impact the pH. And so typically with biochar, it can be used or thought of kind of like an agricultural lime. The majority of biochars, not all, tend to be on the more basic side or have a higher pH, so they will raise the pH. So typically, and that question was about supplementing or the effect on the pH. So it will likely have some effect, and that's why it's important to measure pH at the end of the composting process. And there's a wide range that's acceptable there. So a small substitution of a high pH biochar, for example, is not going to have a tremendous effect on the overall pH of that final compost, but it's certainly something to quantify at the end of the production of that batch of compost. If you're using it with shrubs and trees rather than agricultural product, yeah, I mean, I think that's okay. Obviously, I think Mina knows more about the optimum pH range of ornamental plantings of shrubs and trees, so that's just something to be aware of, and kind of monitor what is the starting pH of the soil within that landscape or ornamental production, and then, you know, maybe measure it the following year and see, did my compost or biochar application change that pH? If you know, if you're not putting on excessive amounts of the material, that pH change is not going to be, you know, disastrous, but it's just something certainly to be aware of. And also pH is going to be affected on whether you're just top dressing those trees or shrubs, or you're actually incorporating it into the soil. So just another thing.
I mean, I think what a lot of people are doing now with the biochar is they are injecting it. You know,
system?
Yeah, into that liquid, so into the root system, and as a way to improve the structure around like a compacted zone within that root zone, but then also I think to infuse it with microbial activity as well.
It's interesting you say that, because I think if you are injecting, so if you're basically, you have really pulverized biochar that then you're suspending in some type of liquid slurry, in this case water, and injecting it, you're really not going to get those structural improvements that you're hoping for, because the powder is so fine.
Yeah, but you know, I just watched a presentation on this on oh God, I guess that was Monday, and it was research that's being done, and they're, you know, testing these various types of injection systems. And yes, I guess prior research has shown when you do these injection systems over time, it just settles, right? And you lose any of that benefit of improving structure. But now I guess they're seeing some positive effect with use of, I think, more coarser biochar, but I don't know the sizes of the particles that they're using. So I think it will be interesting to see where this research goes and if it does provide improvement. But so far it looks promising, at least that's what I was told.
Yeah, no, that's really interesting to hear, and thanks for sharing that, because I have been receiving a lot of questions about particle size of biochar and like what is the optimum one to produce. And I think once again, it's important, what is the end application, and also what is your soil type, what is your soil texture. That has a really profound impact on structure and aggregation and things like that. So it's important, and I can send tons of information on this, but there's a whole national project right now on trying to provide producers or end users with recommendations of what is the most appropriate biochar for a soil type, and link those up based on what is your intended goal for adding biochar. So if you're looking for kind of structural improvements or building organic matter or things like that. So